So Jack is shopping for Christmas presents and realizes everything is sold at summer things are sold at discount prices. So he decides to buy something for himself instead. So a pair of sunglasses being sold at 25% off the regular price of $14.98. How much of a discount will Jack receive? Okay, so make sure first of all that you have a sense of how we can draw this out. I'm just going to draw the $14 and 98 cents in a fraction bar here. Okay, and this represents 0%. This represents 100%. Okay, so this fraction bar comparison, this is actually also called a double number line comparison. It's proportional to each other. Okay, so there's a scale factor from one to the other. In fact, we can see the scale factor here. If I divide 1498 by 100%, I get 4.1498, which basically represents 1%. Okay, so if I divide that, the top here, by 100, I get the unit rate of 1%. Okay, so that's our scale factor when we're going from the top line to the bottom line. So how does this work and when we're talking about this problem? Well, we don't necessarily have to use that scale factor, but we should always understand that's implied and it exists, and we can use that to help us out if we need to. But for the most part, most of us have a good sense of 25%. So this is going to be my 25%. That's my discount. Yeah, maybe I'll do that in a different color here. So my discount is 25%, and that's going to be my 25% bar in here. Okay, so as a percentage, that's 25%. This represents the part that we paid. The amount that we're paying must be 75% then. So this is representing 75% in this area here. So we can do it as a number on the number line, we can do it as area. Okay, so this is our proportion. What percent is the discount? Well, if I take 25% of $14.98, so 0.25 times $14.98, I get $3.75. So the discount is $3.75. Now I can subtract that from $14.98 to get the 75%. Okay, so I better write down my answer first. So it's $3.75. Okay, or I can just subtract. So there's two ways to do it. I can do, I'll show this in two different ways. So one way we can solve this problem for part B is we can take $14.98 and we can subtract $3.75. Okay, and we get $11.23 approximately. We could also do this in a different way. We can actually say we're going to calculate 75%. And so we're going to use a multiplier to do that because it's a proportion. So we can do 1498 times 75%. Okay, and that's going to give us $11, and it doesn't give us, I think it gives us 11.24. Let me just see, 14.98 times 0.75. Yeah, it gives us 24 cents when we round, but essentially it's the same because it's the errors in the rounding there. Okay, so we're going to say this is $11.24. There's a kind of an extra cent in there because of the way it rounded. But there's two different ways we can do this. Now, I think it's good to stick with one operation. Okay, so it's really important to start understanding the multiplying strategy for this. And if we understand the multiplying strategy, we can be consistent with our math, and it's difficult to mix up and make complicated if it's all just times and divide. So I'm just going to show one other way we can do, I want to just make sure that we can still put this in our proportion. Okay, to solve this proportional problem, I'm going to do 1498 compared to, I'm going to do x to 1498 is equal to, there's my 100%, there's my 70%, and 75, sorry. And then we have our multiplier of 0.75. Okay, so that's another strategy we can use. So I'm going to call that B3. Okay, B3 really is related to B2 because it's a times and divide strategy. It's just setting up in the proportion. Okay, so the baseball glove is marked down to $42.50. Okay, let's make sure we can draw our double number line here. Here our fraction bar, we can think of it as. Okay, so this is our fraction bars. This is 100%. Okay, this is 0%. Here's $0. 40% off. That's our 40% in here. That's our 40% discount. I'm just going to write it in here as minus 40%. Okay, and again, if we can use it, if we can avoid the minus, that's going to be much better. And the $42.50 is going to be fitting right in there. So $42.50. Okay, and this is the amount of money that we're trying to figure out, the original price. So this is, if I discount 40%, I can, and this represents my 60%. Okay, so I can say that, well, I can do a proportion up and down. I can do a proportion this way. Okay, so I'm going to just do my 60% comparison because I think that's kind of the easiest way. So I'm going to say 60% compared to 100% is equal to the $42.50 compared to the total price. I have my decimal multiplier here. This is my percentage multiplier. And it looks like I'm going in the opposite direction. So instead of multiplying by that 60%, I'm going to divide by that 60%. Okay, so when I do that, okay, I go $42.50 divided by the 60%. It gives me $70.83. So X equals $70.83. Okay, so that represents the original price. So I want to show something here, and I want you to show you that this is actually the up and down multiplier. Sorry, the left and right multiplier. I can divide $42.50 by 60%. And when I do that, just going to put this off the side. When I do that, I'm going to get a unit rate per percent. So I get $42.50 divided by 60%. And that gives me 70.7083. Okay, so this is going to be $0.7083 for 1%. Well, if that's how much 1% is, I can multiply by 100 to get my 100%. Okay, so then I can do my 100%. That's basically my scale factor going up and down. Okay, it's going that way, but it's also the scale factor going in this direction. Okay, that's going to be times 0.7083. And I can use that same multiplier here. Okay, so there, my 100%, my multiplier for 100, I just times by 100, and I'm going to get the 100% price of $70.83. Essentially, all I've really done is turn this ratio on its side. So I'm just showing the left and right multiplier is just showing up in the vertical direction now. Okay, so if we really understand proportions, we should be able to switch between one from the other. We should understand that this unit rate here of 70.7083 can be used as this comparison left and right, as well as we can do the 60% comparison as well. And this is an important thing to understand, that there are two different directions for this proportion, and as long as we're keeping times and divide, we should be aware that we can use both to solve this problem. Okay, so this one here, we have bathing suits marked down from $85 to $55. So I'm just going to write it as part to whole is equal to part to whole. And so this is going to be the X represents the amount that I paid. Okay, so this would be amount paid. Now I really just want to solve directly for the amount discount. So my discount was $30. And I could just work this out this way. I'm going to call this Y percent to 100%. And this is the amount of my discount. Now, you could work out the percentage paid and then figure the discount afterwards, but I'm just going to do it directly. And so here I have my percentage. I'm just going to do 30 divided by 85. And that gives me a 35.29. So my Y percentage discount is equal to 0.3529, which I'm going to convert to percentage of 35.29%. Okay, so we can do this directly using this. And what's nice about doing it this way is that we are avoiding any addition and subtraction which can mess up our ratios. So there is some advantage to doing this, although there's nothing wrong with doing it the other way as well. But understand that if we can get rid of the add and subtracts, it cleans up our mathematics considerably. And that can be real helpful for the really hard problems.